So far we have solved 15 problems and this is the 16th problem in probability theory. See the question, probability of A, probability of B and probability of A union B are given and you are supposed to find these conditional probabilities. And you know, for computing the conditional probabilities you need probability of A intersection B, for which we are going to use addition theorem. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. I take that probability of A intersection B to the other side and probability of A union B to the right side. So I get 2 by 3 plus 3 by 5 minus 5 by 6. Should take 30 as the LCM. So you have 20 plus 18 minus 25. So the answer is 13 by 30. Probability of A intersection B, which we require for calculating these conditional probabilities. Let us come to the first question. What is probability of A given B? It is probability of A intersection B divided by probability of B. Okay. Probability of A intersection B is 13 by 30. Probability of B is given as 3 by 5. So you have 13 by 30 into 5 by 3. So 13 by 18 is the answer. Okay. 5 6 are 30. You get 18. Now probability of B given A. It is probability of A intersection B divided by probability of A. Probability of A intersection B, we have computed it as 13 by 30. Probability of A is 2 by 3. So 13 by 30 into 3 by 2, you get 13 by 20. Okay. Next, probability of A bar given B. It is probability of A bar intersection B divided by probability of B. You know the answer for this is, we have done it repeatedly, probability of B minus probability of A intersection B. Fine. Now probability of B is 3 by 5. Probability of A intersection B is 13 by 30. Probability of B is 3 by 5. So on simplification, you get 5 by 30 into 5 by 3, 5 by 18. Now let us come to the next question. What is probability of A given B bar? Okay. Probability of A given B bar is probability of A intersection B bar divided by probability of B bar. You know the answer for this is probability of A minus probability of A intersection B divided by 1 minus probability of B. Probability of A is 2 by 3. Probability of A intersection B is 13 by 30 and this is 1 minus 3 by 5. So if you take 30 as the LCM, you get 20 minus 13 here and 5 minus 3 by 5, 5 minus 3 is 2 by 5. So it is 7 by 30 into 5 by 2. The answer is 7 by 12. Okay. And what else to do? Probability of A given B bar is also over. We should do probability of A bar given B bar, which is equal to probability of A bar intersection B bar divided by probability of B bar. This can be written as, by De Morgan's law, probability of A union B the whole bar divided by probability of B bar, which is equal to 1 minus probability of A union B, 1 minus probability of B in the denominator. So you have 1 minus probability of A union B is given as 5 by 6 divided by probability of B bar, 1 minus probability of B is 3 by 5. So you have 1 by 6 into 5 by 2. So the answer is 5 by 12. Okay. So this problem 16 we have worked out. all these answers. Now let us go to problem 17. See, if A, B and C are mutually exclusive events, and if 3P of A equal to 2P of B equal to 6P of C, find P of A union B. See, A, B and C are mutually exclusive. Means what? Probability of A plus probability of B plus probability of C is equal to 1. Let us try to express everything in terms of probability of A, right? So, 3P of A equal to 2P of B implies probability of B is 3 by 2P of A, okay? 3P of A equal to 6P of C implies probability of C is 3 by 6P of A, right? Let us use these. So P of A I am going to retain as P of A. P of B I write it as 3 by 2 P of A. P of C I write it as 3 by 6 P of A. Right? The answer is equal to 1, which implies probability of A is 1 plus 3 by 2 plus 1 by 2. Right? Probability of A is taken out as the constant term. So I have 2 plus 3 plus 1. 2 is taken as the LCM. So I have probability of A into 6 by 2 equal to 1, which implies probability of A is equal to 1 by 3. Okay. If probability of A is 1 by 3, probability of B is 3 by 2 into probability of A. It is 1 by 2. Okay. And I need not find probability of C here, that is not required. We require probability of A union B, and A, B and C are mutually exclusive, means I can stop with P of A plus P of B, and even if I write the third term probability of A intersection B, since A and B are mutually exclusive, this probability becomes 0. So the answer is 1 by 3 plus 1 by 2. Right? Take 6 as the LCM. So the answer is 5 by 6. Fine? Okay. Let us come to the next question. If probability that A occurs is 0.3 and probability that B occurs is 0.5 and probability that at least one occurs is 0.8. You are supposed to find these two probabilities. Probability of A is 0.3. We may require this. Probability of A bar 1 minus 0.3 is 0.7. Probability of B is 0.5. We may require probability of P bar. We shall write it here. 1 minus probability of B is 0.5. And probability that at least one occurs means A union B. Okay, this means A union B. It is 0.8. What is the probability that both will occur? This is the question. Okay, probability that both occur. So that is equal to probability of A plus probability of B minus probability of A union B. Okay, 0.3 plus 0.5 minus 0.8. The answer is 0. It means that A and B are mutually exclusive. What is the probability that none will occur? That is probability that A will not occur and B will not occur. This is what we require. Instead, we can write it as 1 minus probability that at least one will occur. Actually, if you go by this, if you write it by De Morgan's law as probability of A union B the whole bar, again you are going to get this only. So, 1 minus at least one, the probability is given as 0.8. So, the answer is 0.2. Okay, fine. Thank you.